It all hinges on carefully managing the balance of carbon and nitrogen in the water, usually aiming for a ratio somewhere between, say, 10-1 and 15-1.
Okay.
And hitting that sweet spot really encourages specific types of bacteria, the heterotrophic ones, to thrive. These are the workhorses. They take up nitrogen compounds like ammonia directly from the water and convert them into microbial protein.
Right.
And these proteins then aggregate with algae, protozoa, bits of organic matter, forming these clumps we call flocs.
So these flocs are cleaning the water and becoming food themselves. That's the dual function.
That's exactly it. They're both a waste treatment system and a sort of built-in nutritional source for the shrimp.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
Imagine meeting this huge global appetite for seafood, especially shrimp, but doing it sustainably, without, exhausting resources or impacting waterways. Seems almost futuristic. But today, we're diving into something that makes that quite real, Biofloc technology. You've likely heard about it, but we want to really unpack what makes it such a potential game changer for aquaculture.
It's fascinating because this approach isn't just tweaking old methods. It's fundamentally rethinking the farming process. It really leverages microbial communities to create a much more, let's say, closed-loop system. And that directly tackles major industry pain points.
Like feed dependency and environmental discharge.
Exactly. Feed resources, waste impact, water usage, the traditional constraints. Biofloc offers a way to move past that high input, high waste model.
So the core idea, transforming waste right in the system into something useful, it sounds incredibly efficient. How does that actually work down at the microbial level? It's not just passive, right?
Yeah.
It's an active biological process.
Precisely. It all hinges on carefully managing the balance of carbon and nitrogen in the water, usually aiming for a ratio somewhere between, say, 10-1 and 15-1.
Okay.
And hitting that sweet spot really encourages specific types of bacteria, the heterotrophic ones, to thrive. These are the workhorses. They take up nitrogen compounds like ammonia directly from the water and convert them into microbial protein.
Right.
And these proteins then aggregate with algae, protozoa, bits of organic matter, forming these clumps we call flocs.
So these flocs are cleaning the water and becoming food themselves. That's the dual function.
That's exactly it. They're both a waste treatment system and a sort of built-in nutritional source for the shrimp.
Love it.
But maintaining that microbial balance is absolutely key. You need continuous, strong aeration. That keeps the floc suspended and prevents low oxygen zones, which would be disastrous.
Mm-hmm.
And you also need a steady input of a simple carbon source. Molasses is common, or tapioca starch, things like that, to keep that carbon-nitrogen ratio right where you need it. It's a living system you have to manage carefully.
Why Zenetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
Okay, beyond the waste management and the internal nutrition boost, the data points to other big advantages. For the shrimp health itself and for the wider environment, what are the benefits that really catch producers' attention?
Well, they're pretty significant. Nutritionally, those flocs are packed with essential amino acids, lipids, vitamins, micronutrients.
So better shrimp health overall.
Yes, and it means the shrimp have this constant, easily digestible food source available. The big economic impact is reducing reliance on external feeds. Some farms report cutting feed costs by as much as a third.
A third? That's huge.
It really is. It changes the economics significantly, especially where feed costs are a major barrier. And naturally, this leads to much better feed conversion, less feed needed per unit of shrimp produced.
Right, and environmentally.
Equally compelling. Because it's more closed loop, you drastically cut down on water discharge. This minimizes the risk of nutrient pollution in nearby waters. Huge benefit, especially in areas where water is scarce. Makes aquaculture feasible where it otherwise wouldn't be.
Okay, let's get into the numbers that producers really want to know. Stocking densities, feed conversion rates. What kind of performance are we actually seeing compared to traditional methods? And what are the absolute must-manage parameters?
Performance-wise, the figures are impressive. These systems can handle much higher stocking densities. We're talking up to maybe 450 shrimp per cubic meter, often without hurting growth or survival.
450, that's quite a jump from traditional ponds.
A massive jump. And like I said, the feed conversion can get down to around 1.2. Compare that to 1.5, maybe even 2.0 in conventional systems. It really redefines productivity potential.
Wow.
Now, to keep things running smoothly at those densities, you absolutely need dissolved oxygen consistently above, say, 5 milligrams per liter. Stable pH is critical, and you have to keep those nitrogen compounds in check.
And the system design plays a role.
Definitely. Circular tanks are common, often with paddle wheel aerators. These aren't just for oxygen. They're vital for keeping the flock suspended, active, and available to the shrimp throughout the tank. Constant mixing is key.
Okay, it sounds very promising, but let's be realistic. No system like this is without challenges. What are the main hurdles for wider adoption? The things that make it tricky to implement?
You're right, it's not simple. A major one is energy cost, that constant, vigorous aeration needed. It can easily account for over 30% of your operational expenses.
Ouch. That's significant.
It is, and it makes energy price stability really important. Another big factor is expertise. You need people who really understand microbial dynamics, water chemistry. It's complex biological management, not just following a recipe.
So a higher skill requirement for the operators.
Definitely. And that complexity introduces biological risks. If the flock composition shifts the wrong way, you might get poor nutrition, or worse, an increase in harmful bacteria like certain Vibrio species. That can lead to major stock losses.
A delicate balance, then.
Very much so. Then there are the economics. High initial setup costs can be a barrier, and sourcing consistent, affordable carbon locally isn't always straightforward.
Right, the input cost.
And finally, market perception. While the shrimp quality is often excellent, consumers aren't necessarily seeking out Biofloc shrimp yet. Getting a premium price can be tough, though good quality usually wins out eventually. It takes time to build that awareness.
Okay, clear hurdles. But innovation is constant. What's on the horizon? What research and tech developments are aiming to smooth out these rough edges?
There's a lot of exciting work happening. Automation is a huge focus. Think IoT sensors constantly monitoring conditions, oxygen, that carbon-nitrogen balance, microbial load.
Real-time data.
Exactly. Feeding into AI systems that can predict problems and automatically adjust aeration or carbon dosing. That could take a lot of the complex manual management out of it, reducing labor and risk.
Makes sense.
Then there's better microbial management. Using tools like metagenomics to really understand the microbial community, maybe even selecting or engineering beneficial strains to make the flocks more stable, nutritious, and resistant to pathogens.
Fine-tuning the ecosystem itself. Very interesting. What about the inputs?
Also a big area. Research into alternative carbon sources is ongoing, using things like microalgae, biochar, various agricultural byproducts, trying to find cheaper, more sustainable, locally available options.
Right, reducing reliance on things like molasses.
Precisely. And also integrating these systems, combining them with other types of aquaculture like growing seaweed or shellfish nearby to utilize any nutrient outflow, creating more diverse and resilient farm systems.
So, moving beyond the tech, what about the surrounding factors? Policy, training, education. How crucial are those for making this technology truly take root?
Absolutely critical. You can have the best tech, but without the right support structure, it won't scale. Supportive policies are essential, things like subsidies or grants to help with those initial setup costs, incentives for research.
Making it easier to adopt.
Yes. And massive investment in training. We need programs to build the expertise needed on the ground, equipping farmers and technicians with the skills to manage these systems effectively. We've seen success stories in places like Malaysia, Vietnam, where targeted training really boosted success rates.
So empowering the producers directly.
Exactly. Market support helps too. Things like specific certification or eco-labeling for Biofloc products. That can build consumer confidence and potentially open up premium markets.
Adds value recognition.
Right. And finally, standardization. Getting agreement on best practices and protocols supported by industry bodies and government ensures consistency and helps validate the sustainability claims, avoids confusion, and builds trust.
So, pulling it all together, what's the big picture for shrimp farming? It really sounds like this isn't just a minor improvement, but potentially a fundamental shift towards more sustainable, more productive aquaculture.
I think that's fair to say. It really demonstrates how understanding and managing complex biological systems can provide powerful solutions for food production challenges. It hits sustainability, productivity, environmental care all at once.
A more circular approach.
Exactly. Now, the journey isn't over. There are still real challenges, technical, biological, economic. But the direction seems clear. The ongoing innovations are making these systems more robust, more efficient, more accessible. It feels like we're moving towards wider adoption.
So as you listening, think about this deep dive. Maybe the question isn't just about the efficiency of this specific technology for shrimp. Perhaps it's broader. What other complex agricultural systems could benefit from similar, microbial-driven transformations? And what will it take to unlock that potential?
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.